Good morning, you guys. Today is Monday, May 11th, and we are really getting down to the home stretch here. We're on to our second to last Monday. We've got 2 weeks left. We've got basically 5 instructional days, 5 clarification days. So just kind of bear with me, hang in there. We're down to, like I said, the home stretch, okay? What we're going to spend our last 2 weeks here doing is, and this, I cannot stress this enough, so I'm hoping that even if you guys haven't really been keeping up with the homework, you're still watching the videos. These last 2 weeks are really vital for you guys in terms of if you're taking a calculus class next year in college, it's really going to be beneficial that you guys see and hear the terminology here, okay? So we're into chapter 5, and chapter 5 is all about integration. Okay, so I'm going to do my best to explain to you guys what integration is and for you to see how these terms apply and where they are used, okay? So what integration is, and this kind of goes with like the most fundamental basic thing about math, which is why I decided to be a math teacher, okay? You guys know how organized I am, how detailed I am, and how balanced I am. So that's that word balance is really the key to this discussion, okay? Math is balanced. Everything in math has an opposite. Everything that you do, you can undo. Everything has an opposite, okay? So what I'm really going to kind of explain here and just jot down to get started before we get into how to do integration, I want to explain what integration is, okay? So it all goes down to opposites, all right? Differentiation is the act of finding a derivative, okay? So when we say differentiation, this is an act. It's something that we're doing. We're doing differentiation when we're finding derivatives, okay? A derivative. I misspell this stuff all the time. So differentiation is the process or the act of finding a derivative, okay? The opposite. So again, multiplying and dividing. Multiplying has division. Addition has subtraction. Differentiation has integration, okay? So the opposite of differentiation is called integration. Okay, so when we differentiate, we're finding a derivative of a function. Okay, so the opposite of differentiation is integration. The opposite of finding a derivative is finding an integral. Okay, and what you're going to see today is these are going to be called indefinite integrals, which means generic or general integrals. Indefinite is general, okay? So what you're going to see today is the directions are going to say, find the indefinite integral of each of your things, okay? So instead of finding the derivative, we're going to be finding the indefinite integral. The process that we're going to be doing is called integration. So I'm going to just kind of show you a real simple example here. If we take a function, y equals 3x squared plus 5, okay? The act of differentiation or finding the derivative, and we all know that derivatives, the simplest way of demonstrating or marking a derivative is just with this little prime symbol. We know the process of differentiating a simple polynomial function. You bring the exponent down, you multiply it by whatever's out front, so 2 times 3 is 6, and then we subtract 1 from the exponent, okay? And then if something doesn't have a variable, it just basically becomes 0 because technically, to follow the rules, this would be 5x to the 0. 0 times 5 is 0. 0 wipes out anything. So this is the act of finding a derivative. Okay, now, if I take that 6x to the first power, all right? If I take that and I want to do the exact opposite, I want to work backwards and get back to what the original function was. The opposite of finding a derivative is finding an indefinite integral. So we all know the symbol for finding a derivative. It's this little prime symbol. The symbol for finding an integral, which means the symbol for integration, is kind of a goofy looking thing. It's this elongated looking curve. It's kind of like an S curve. That is called the integration symbol. So if I ask you to integrate the function, I'm asking you to integrate 6x. So the process, I'm going to show you the process, and it's not too terribly difficult, you guys, I promise. There's a simple way of doing this, especially for polynomials. But what I want you to see is this. Essentially, where does this 6x come from? Well, it comes from the fact that this is an x to the first power, which means it was an x to the second power, okay? And then if we just think about it, if it was an x to the second power, and when we differentiated, it became 6 out front, that must have meant it was a 3 at the beginning. It was 3x to the second power because when we subtracted 1, it became x to the 1, and then when we multiplied the two things, it became a 6. So the only way that became a 6 from a 2 was if it had a 3 out front. So that just means my original function for y had to have been a 3x squared. Now here's the thing. We also know that potentially from a 6x, if this is what you got when you differentiated, there could have been a constant here, right? The thing is this. Every constant, when you differentiate, becomes 0. So when you do the opposite, when you integrate, it's also called anti-differentiation or the antiderivative, okay? That's the thing I didn't really put in here, but I'll kind of jot it down in just a second here. You have to recognize that when you do the antiderivative or when you integrate, there's always the possibility that there was a constant to start with, but we don't know what that constant was. So what we do is we just put plus c there because there could have been a constant there. Maybe it was a 5, but there's no way of knowing what it originally was, okay? So this is kind of what we're getting at today, is the opposite of differentiating is integrating, okay? Or doing integration, finding an indefinite integral. And it means working backwards to an original function from what was potentially its derivative. So, integration, another word for integration is anti-differentiation. Okay, so there's a lot of different words or a lot of different, kind of spin-offs of these words. We have integration and anti-differentiation. You can integrate, you can anti-differentiate. You can find an integral, you can find an antiderivative. They all are synonymous. They all mean the same thing, okay? So if I ask you guys, and I think on your assignment today, they might use these words interchangeably. They might not say find the indefinite integral. They might just say find the antiderivative, okay? It's just the opposite of differentiation. So I'm going to give you another example. Before I show you the actual process or the actual method of doing this, I want to just give you an example here. So if I give you just an expression, okay? If I give you the expression, I don't even know. It's almost hard to come up with them off the top of your head here. 2x plus 5. There's a decent one. 2x plus 5. And I ask you to integrate that. This is the symbol for integration. This means if this is the function y equals 2x plus 5, and it's the derivative of a larger function, what would that larger function have been? So if you think about this, this is a 1 right now. It's 2x to the first power. If this is the derivative of a function, that means that this 1 would have started out as a 2. But when we found the derivative of it, we brought the 2 out front, it became 2x to the first power. That's exactly what this is. So what's the antiderivative of 2x? It's x squared. It's the exact opposite of differentiating, okay? Where would this 5 have come from? Well, think about this. When we differentiate and we get a constant, that just means that came from a generic x. So this would have been plus 5x. So hopefully you can see here, we're used to doing this. We're used to taking x squared plus 5x and differentiating it. Bring the 2 down, subtract 1, it becomes 2x to the first power. That's this. What's the derivative of 5x? It's just 5. Now, we're working backwards. But what we have to recognize here is this, okay? The antiderivative of 2x is x squared. The antiderivative of plus 5 is plus 5x. But if this is the derivative, there could have been a constant at the end. We just have no way of knowing what it would have been. So what you're going to do a whole lot of in these last 2 weeks here is this. You're going to see this. And I wish I had a little bit more time here, but my college professor, the very first day of class, he walked in and before saying a word, he took a marker and on the cement wall above the chalkboard, what he did was and on a single block, he wrote in marker plus C. Okay, and I never took calculus in high school, so I was completely confused with what he was doing. I thought he was a crazy person. But the whole point is, anytime you do integration, the last thing you have to remember so that you don't get every single question wrong, this was the point he was trying to make, is never forget to add C to the end when you're doing integration, okay? Because there's always the potential for a constant. So what would the derivative of this function be? 2x, there's the 2x, plus 5, and any constant becomes 0, which means we get rid of it. Now, I'm going to show you some examples of how do you actually do it, okay? So the directions today, for the most part, are going to say find the indefinite integral, and they're just going to give you an expression. So they're going to give you something maybe like this. 1 over x to the negative third power, and they're going to have that integral sign in front of it. That means find the antiderivative of that function. So what we're going to do is we're going to do a lot of the same stuff we usually do. Before we actually do any kind of integration, we're going to try and clean that up. We're going to try and turn it into just a single polynomial expression. So what is another way of writing 1 over x to the negative, or excuse me, that should have been a positive 3. I apologize. 1 over x to the third, that we could write it as x to the negative third. Okay, I'm going to show you how to do integration the shortcut way. The shortcut way is this. You put your term, whether it's got a constant or a coefficient out front or not, you put the term, okay, you add 1 to the exponent. Instead of subtracting 1 when we do integration, we add 1. So what is negative 3 plus 1? It's negative 2, okay? And then you put that whole thing over whatever that exponent was when you added 1 to it. So you put the whole thing over negative 2, and then we simplify, okay? So, or we manipulate this so that it makes a little bit more sense. So what makes sense here is to move the x to the bottom, so it becomes x squared on the bottom. There's a 2 on the bottom. When we clear the top, it means it becomes a 1 on the top, and then I can kind of move that negative sign instead of being tucked into the bottom there. We just move it out front. Here's the integral of 1 over x to the third. It becomes negative 1 over 2 x squared. Now, I want to prove it to you. If I rewrite this by moving the x back up front and pulling it off to the side, this would be negative 1/2 x to the negative 2. Here's my negative 1/2. Move x to the top, it becomes negative 2. If you were to differentiate this, so if this is the equation, y equals, and I look at what I did right there, right out of the gate. I forgot to put plus c. Right? I haven't done integration in a year, so I like it right out of the gate. I messed that up. Okay, if I differentiate this though, you do negative 2 times negative 1/2. What's negative 2 times negative 1/2? That would be positive 1. This would become x to the negative third. Okay, and if you look at this, 1x to the negative 3, we would move that to the bottom. It would become 1 over x to the third. So hopefully that helps you to kind of justify it in your head that, okay, yeah, that worked. Let me just show you kind of a whole slew more of these examples, okay? Let me give you another expression here. Let's go with this one. 4x squared, or sorry, it's supposed to be a cube. I'm pulling them off my note sheet. 4x cubed minus 5x plus 2. Let's find the integral, the indefinite integral for that. And again, finding the indefinite integral means finding the antiderivative. So how do we do this? This is the process you're going to replicate a whole bunch of times today, you guys, okay? Whatever each individual term is. So this is 4x to the third. Take 4x, raise the exponent by 1, so it becomes to the fourth. Put it over whatever that exponent was. So whatever the exponent becomes, you put that as the bottom of a fraction. So here's going to be my first term of my antiderivative. Minus 5x. Raise the exponent by 1, so it becomes 2. Put it over 2. Plus 2, any constant just becomes, you put an x on it because we're finding the antiderivative, so instead of removing the x, we put the x on it. Technically, you'd be going from an x to the 0 to an x to the 1, but then if you put that over 1, nothing changes anyways. And then, like I said before, don't forget to put plus c. All right, let me clean this up here. What do the 4's do? The 4's cancel perfectly. You're left with x to the fourth. Here, this does not clean up nicely, so you can just leave it as minus 5 halves x squared plus 2x plus c. There is your antiderivative, or your indefinite integral from this function. If we think in reverse here, if you found the derivative of this, would you get back here? What's the derivative of x to the fourth? 4x cubed. What's the derivative of negative 5 halves x squared? The 2's would cancel, you'd be left with negative 5x. That's there. What's the derivative of 2x? 2. And the derivative of a constant is 0. It goes away. Okay? So ultimately, that's how we anti-differentiate. That's how we find antiderivatives, is you take every individual term, raise the exponent by 1, put it over that new exponent, okay, and then simplify from there. What you're going to see today, the challenge for today, is going to be cleaning up some of these expressions. So I know I'm going to go a little bit long today, but I need to show you at least 2 more examples just to make sure that things make sense, okay? So here's the next example. It's going to be a compound or a complex fraction, x plus 1 over the square root of x. We're going to anti-differentiate that. We're going to find the indefinite integral. Here's what you're going to do. Before you do anything with it, you're going to try and rewrite this as a polynomial. As ugly as it might be, you're going to try and just manipulate it. So I'm going to start by turning this into a fractional exponent. Instead of square root of x, it's x to the 1/2 power. Now I'm going to break this up. This is a complex fraction, so I can break it up like this. X over x to the 1/2, subtract exponents. This is x to the first over x to the 1/2, which gives me just an x to the 1/2. When we think about just canceling out, this is 1 minus a half, which is a half. Now, this other one doesn't break up in anything. It's 1 over x to the 1/2 power, right? This portion of that. If I turn this or move this x up with the 1, here's what I get. X to the 1/2 plus 1x to the negative 1/2. At this point, hopefully this makes sense to you, we've got it as a term plus another term is written basically loosely in polynomial form. Now, integrate it. Okay, so how do we do integration? We take each term, this one is just x, raise its exponent by 1. So this becomes x to the 3/2 power, but then divide it by that. Divide it by 3/2. This next term right here, this is plus 1x. Raise that exponent by 1. What's negative 1/2 plus 1? That would be positive 1/2, and then divide it by that same thing. So when you have rational exponents, you're going to have some ugly fractions. You're going to have to do this as keep, change, flip. You're going to keep the top the same, change dividing into multiplying by the reciprocal. So what this becomes, if you think about it, it's x to the 3/2, x to the 3/2 power. Instead of dividing, it's going to be multiplying by the reciprocal. So what's the reciprocal of 3/2? That would be 2/3. So that becomes 2/3 x to the 3/2. Similar here, plus x to the 1/2 power, but instead of divided by a half, it's multiplied by the reciprocal. What's the reciprocal of 1 over 2? That would be 2 over 1, or just 2. Don't forget your plus c, and if I just rewrite this real nicely, 2/3 x to the 3/2 power plus 2x to the 1/2 power plus c. That's how we're going to leave all of our stuff today. We're going to leave it all with positive exponents. If you think about this, this would differentiate right back to here. 3/2 times 2/3 would be 1. Drop this exponent down by 1. So 3/2 minus 1 would be 1/2. This would be 1x to the 1/2 power. That's exactly what we have right here. Do the same thing here. Multiply 1/2 and 2, you get 1. Subtract that 1 from this exponent, it would be x to the negative 1/2. That's right there. The derivative of any constant is 0. Okay? So I'm going to show you one more. I apologize. I know this video is getting kind of long, but I don't want anybody to just kind of like feel completely abandoned when you get to the assignment today. Okay? I want to find one last good example here. Let's go. Here's a good one. Cube root of x minus 1 over 2 times the cube root of x. Let's find the antiderivative here. So the first thing we need to do to these is just manipulate this. So the first term's not so bad. That's just x to the 1/3 power. The second one, this becomes minus 1/2. Okay, if I turn this into an exponent, it would be, there's my 1 and my 1/2 is right there. This is x to the 1/3 power, but I need to move it to the top, so it becomes negative, x to the negative 1/3 power. Okay, so the first thing you're going to do today is any of these, you're going to try and just rewrite them. That might mean you need to FOIL today. You might need to multiply things, combine like bases, whatever the case may be, but you need to get it down looking like something like that so that you can do the integration. Integration is take the term, the first term is just x, add 1, so that becomes 4/3, divide by the new exponent, divided by 4/3. So this is going to be similar. You're going to leave x to the 4/3, but you're going to change it from divided by 4/3 to multiplied by the reciprocal. The reciprocal of 4/3 is 3/4. So there it is. This other term, you got minus 1/2 x, so the 1/2 x can just go up top, that's fine. Add 1 to this. This becomes 2/3 over 2/3. Now, when you think about this, before I write my answer down here, this is going to be a minus. Here's my minus sign. I need to change this. 1/2 x to the 2/3 times 3/2. 1/2 x to the 2/3 times 3/2, the reciprocal. So just multiply these. 3 over 1 is 3. Or sorry, 3 times 1, 2 times 2 is 4. So it's 3/4 x to the 2/3 power, and then don't forget to put your plus c on there. That's how you're going to write all your answers. You're not going to combine them back. I don't think the back of the book's going to have you trying to get common denominators or anything like that. I'm pretty sure they're going to just leave it written in polynomial form. Okay? If we have, and I'm sure you guys will, I'm sure you'll have some questions because this is your first run on integration, antiderivative, stuff like that. Do your best, work to the back of the book, try and get to where they have their answers, and then let me know what kinds of questions you guys have. All right? And then we'll have a clarification video tomorrow to try and get things answered. All right, guys, I'm going to cut it off there. Sorry I ran long. Do your best. Let me know what your questions are. Have a great day.